Good day, young learners. I am Gilbert F. Lopez, a BSc3 major in mathematics student from Northern Mindanao Colleges Incorporated. For today's video tutorial, I will be discussing evaluating algebraic expressions. Objectives in this video lessons. First, recall the rules in operations on integers, components of algebraic expression, termed as an exponential notation. And second, evaluate mathematical expressions for the given values of the variable. But before we proceed, let's have first a sort of review for us to remember and what will not be, or we will not be confused with regards with this topic. So let's have a review first. So let us take back our memories, especially on the rules of integers, the basic arithmetic operations, and even exponential notations, and also some components of an algebraic expressions. So let's have first algebraic expression. So by the way, what is algebraic expression? So algebraic expression is a combination of terms by the operations such as addition, subtraction, multiplication, division, and etc. So let us have an example. So this one, 10x cubed plus y minus 2. So this is an example of an algebraic expressions or expression. What are the components of an algebraic expression? So algebraic expressions have components which is constant of the variable and the coefficient. So constant is any real number. So example, 5, 6, 3, 23, and pi. So pi is considered constant because it has an approximate value of 3.1415. So what is variable? Variables is any letters used to represent numbers that are not known. So any alphabet or any letter from alphabet. So example, X, Y, Z, D, S, T. So coefficient. Coefficient is the numerical factor of a monomial. So example, 4x. So 4 is the coefficient. So let us now proceed with operation on integers. So in integers or integer rules for addition and subtraction, always remember in addition and subtraction, if it has the same sign, add and then take the sign. If they are in different signs, subtract and take the sign of the largest absolute value. So we have an example here. So in addition, if they are in the same sign, so take the sign. If they are in different signs, so subtract and take the sign of the largest absolute value. So in subtraction, to subtract an integer from another integers, the sign of the number which is to be subtracted should be changed, and then this number with the change sign should be added to the first number. So this one. So you have to subtract and change the number or the sign of that particular number. In operation of integers for multiplication and division, if they are in the same sign, the answer is positive. So if they have in different sign, the answer will be negative. So always remember that. So let us not forget those basic arithmetic operations and rules of integers. So here, let us review exponential notation. So there are some components also of an exponential notation. So they are the base, exponent, and power. So base are a given number that is being multiplied. So exponent tell how many times the base is used as a factor. Power is the product of the equal factors. So we have here an example. So 3 squared. So 3 is our base, 2 is our exponent, and the product of that particular number is 9. So that is our power. So another example, 7 cubed. So 7 is our base, the exponent is 3, and the product is 343. We also have exponential notations. So by the way, this is a sort of review. So here we have some example of exponential notation. So xa squared b cubed. Another 4x squared or 4 squared x cubed y to the 4th. Next is quantity of negative 3 squared. And last is negative 3 squared. So in this example of exponential notation, how will we use or write it in an expanded notation? So this, so here 6a squared b cubed, since 6 has no exponent, so you have to write it once. Then our a has a power of 2, or it is being raised to the power of 2, so you have to write it twice or 2 times. Then our b cubed, so b is raised to the power of 3, so we have to write it in 3 times. So this one. So how about 4 squared x cubed y to the 4th? So since 4 is raised to the power of 2, then we write it twice. Then x cubed, so x is being raised to cube, so you have to write it 3rd times. So this one. And the last is y to the 4th, so you have to write it 4 times. So in this number 3, so the quantity of negative 3 squared, so how we are going to write this one? So multiply negative 3 by itself. Remember, if we see a term which is enclosed by a parenthesis, so this one, parenthesis, so it means they are in the same group. So they are in the same so they are in the same term. So if that enclosed term was raised to a specific exponent, multiply it by the required given exponent. So in this example, we write, or the required was raised to the power of 2. So then you have to multiply it by -3 by itself. So the result is, so -3, or the quantity of -3 times the quantity of -3. So here, -3 squared. So how we are going to write this one? So this is different from this example, the quantity of -3 squared. So that is different from this one. So -3 squared. How we are going to write this one? So take note, if does not have a parenthesis, or it was not enclosed with a parenthesis, so it means only 3. Only this one, only that one will be multiplied by itself. Do not include this sign, the -1. So always remember that. So that negative sign was placed before the number, so only the 3, 1 will be multiplied by itself. So our answer will be, so this one, only this one, so the 3, 1. So you have to multiply 3. Do not include this sign. So always remember, if it's, or if there's no parenthesis inclusion, so do not multiply it by itself. So how about we are going to evaluate exponential notation? So we have learned, since we already know how to write exponential notation and its expanded notation, so let's now try to evaluate them. So this one, the quantity of -3 squared. So in expanded notation, so quantity of -3 times the quantity of -3. So if we are going to evaluate it, so if you remember the rules of integers, if the two in multiplication, if two the same sign, so the answer will be +9. So let's have another example. So -3 squared. So in expanded notation, this one, so they are in different signs, so negative and the positive. So if we are going to multiply this different sign, negative and positive, so the result would be -9. So another one, so quantity of 1/2 squared. So in expanded notation, we have quantity of 1/2, so you have to multiply it by itself. So another quantity of 1/2. So if we are going to multiply it, 1 times 1, this one, 1 times 1 is 1. 2 times 2, that would be 1/4. So let us now proceed with our main topic, which is evaluating algebraic expressions. Since we already discussed a matter of review, or we have a matter of review on exponential notation, evaluation, or two evaluation, which is relevant to my topic for this video lesson. So what is meant by evaluating algebraic expression? So evaluating algebraic expression means to replace, take note, to replace a variable by a particular value to simplify the expression. So always remember to replace a variable. So the other one, we evaluate an expression by substituting. So when you replace a variable, it means you do substitution. So the value of the variable and finding the value of the expression. So let's have some examples. For example, so evaluate the following. So remember that our variables, the value is given, so don't be confused of that, because our variable has given a specific value. So number 1, 7x. So when x is equals to 5, so take note that our variables are given. So all you have to do is copy this one, the 7, and substitute the value of our x, which is 5. So always remember that when the coefficient and the variables, this variable are in the same term, it simply means you have to multiply it. So 7 times 5, so it gives us an answer of 35. So let's have another example. So 6ab, when a is equals to 2, b is equal to -3. So what we are going to do, so copy 6a, or copy 6, -6, then replace or substitute the value of our variable. So the value of our a is 2 and the value of our b is -3. So what we are going next, so next is multiply this one. So -6 times 2, or you can also multiply this one because it has in the same term, so it doesn't matter. So because it comes up with the same result if you do this, or if you multiply this first, or this one, the 2 and the -3, it comes up with the same result. So I have here, or I multiply here this one, sorry, I first multiply this one. So this one, the -6, and the +2, it becomes -12. So the remaining is -3. So since they are in the same term, so you have to multiply this. So -12 times -3, it gives us an answer of +36. So if you remember the rules of integers, so if they are in the same, or if you multiply the same sign, so the answer would be positive. So let's let's have another example. So here we have an operation, or the operation of our expression is in 2 terms. So this one, one term, and the second term. So our expression is 4pq minus 7p when p is equal to 2 and q is equal to 5. So copy the given 4, then replace the value of our variables, the p and q. So copy the 4, this one, 4, then replace or substitute the value of our p and q. So our p is 2 and our q is 5. then minus the second term, minus 7 times the value of our p. So what we are going next, so multiply. So 2 times 5, I multiply this one first, so this one, so this term, so 2 times 5 becomes 10, then copy 4 because it is given, so minus 7 2 or times 2, so it becomes negative 14 rather. So 4 times 10 becomes 40 minus 14. So if you remember our rules in integers for subtraction or addition, so you have to, so in the rules of our integers, you have to copy the largest sign of our value of this. So copy the largest absolute value. So since 40 is the largest one, so 40 minus 14, so becomes positive 26. So let's have another example. So here, 8 times the quantity of xy minus 2. When a is equal to 6, x is equal to negative 2 and y is equal to negative 3. What we are going to do this one? So first, substitute the value of our variables. So the value of our a here is 6. The value of our xy, so our x is negative 2. The value of our y is 3. So copy the remaining because it is already given. So we put a bracket in groupings for us to not be confused when we are solving, since we already have parentheses in substitution. So the values of our variables, we have to use other symbols. So I use this one, the bracket. So in performing this kind of expressions, we are going to remember our PEMDAS rules. So in solving, first you have to solve the parentheses, then the exponent, multiplication, division, addition, then subtraction. So let's solve first this inside the bracket. So the negative 2 and the 3 1. So negative 2 times 3 minus 2, because negative 2 is already given, so you have to copy this one. Sorry. So you have to copy this one. So negative 2 times positive 3, negative 2 times positive 3 becomes negative 3 because they are in different signs, so you have, or our answer must be negative. So take note, the 6 is given, so let's solve first this one inside the bracket. So you have to eliminate this one. So negative 6 minus 2, since they are in the same sign, so the answer would be negative 8. So we are going to solve these two because they are remaining, or they are the two remaining. So 6 times negative 8, it gives us the answer of negative 48. So always remember with our PEMDAS rule, so you have to first solve the parentheses, the exponent, then multiplication, division, addition, and the last is subtraction. So we have here example number 5. So this is a fraction. So same procedure with the previous. So we have to substitute the value of our variables. So copy this 6ab over 3a. So 6 and 3 is already given. So you have to substitute the value of our a and b, and also in this one here. So substitute the value of our a and c. So the value of our a is 3, the value of our b is 2. So over 3 times, so the value of our a is 3 and the value of our c is negative 4. Then simplify. So by multiplying, so 6 times 3 becomes 18 because they are in the same sign, so times positive 2. So over 3 times 3 becomes positive 9 and the remaining negative 4. So next is this one. Multiply 18 times 2, it's positive 36. 9 times negative 4, negative 36. So our final answer, since they are in different sign, the rules of integers in division and multiplication, if they are in different signs, so the answer would be negative. So the answer of positive 36 over negative 36 would be negative 1. Here, evaluate algebraic expression or evaluating algebraic expression. So evaluate the following if x is equal to 5, y is equals to 3, and z is equals to 2. So here, number 1, x squared z cubed. So the same procedure. So substitute the value of our variable. So the value of our x is 5. The value of our z is 2. So since 5 is raised to 2, so you have to multiply it by itself. So 5 squared becomes 25, 2 cubed becomes 8. So multiply 25 times 8, positive 200. So number 2, 4x to the 4th, y to the 4th. So the same procedure. So you have to substitute the value of our variables. So 4 times the value of our variable x is 4 or 5. So the value of our y is 3. So 5 to the 4th becomes 625. 3 to the 4th, 81. So simplify it by multiplying. So 4 times 6, 25. 25. So times 81. So it gives us an answer of positive 202. 500 or 202,500. So in example number 3, 5x cubed plus 4z minus y. So same procedure. So substitute the value of our variables. 1. So 5 cubed is, it gives us an answer of 125 plus 4 times the value of our z is 2. The value of our y is 3. So 5 times 125, it gives us 625. So plus 8 minus 3. So remember the rules. So we have to add first. So 625 plus 8 becomes 633. So the remaining is minus 3 or negative 3. So 633 minus 3 becomes 630 because the largest absolute value is positive, so the answer must be positive. So let's have another example. So 4x minus 2yz plus 6xy when x is equal to 2, y is equal to negative 5, and z is equal to 3. So this expression is in trinomial because it has 3 terms, or it is in 3 terms. So the same procedure, so we have to substitute all the values of our variables. So if you know that this one, so you can directly, so the next step is you have to simplify. So you can simplify by terms. So I have here, so I simplify it by terms. So 4 times 2, 8. Then solve it first here. So negative 5 times 3 becomes negative 15. So the remaining is 2 there, the negative 2, plus 6 times 2 times negative 5 becomes negative 10 because it has indifferent sign. Then this one, negative 2 times negative 15 becomes positive 30. So 6 times negative 10, since they are in different terms by the rule of multiplication of integers, so it gives us an answer of negative 60. So first is you have to add. So 8 plus 30 becomes 38 minus 60. So it gives us an answer of negative 22. Let's try another example. So x cubed minus 3xy plus 3yz. So same, it is in trinomial because it has 3 terms. So if x is equal to 1, y is equal to negative 2, and z is equal to negative 3. So same procedure. So substitute all the given values of our variables. So gives us 1 cube minus 3 times 1 times negative 2 plus 3 times negative 2 times 3. So if you need this, you can directly answer. So I have here, so I simplify it. So 1 times, or 1 to the cube is equivalent to 1. So 1 times negative 2, it gives us an answer of negative 2. So plus negative 2 times negative 3, negative 6. So this one, same procedure with the previous. So 1 plus 6 minus 18. So first add this one. So 1 plus 6 is 7 minus 18. Then subtract because we are following the PEMDAS or PEMDAS rule. So 7 minus 18 gives us an answer of negative 11. Another example, so it's a fraction. So 2x cubed plus 2 over 1 minus 2 when x is equal to 3, y is equals to 1. So first step, same procedure with the previous. So you have to substitute all the values of our variables. So given, because since the variables are given, so the values of our variables are given, so you have to substitute it. So 2 times 3 cubed plus 2 over 1 minus 2. So if you know this, you can directly answer. So 2 times positive 27 plus 2 over negative 1. So 2 times 27 equals positive 54 plus 2 over negative 1, because 1 minus 2 is negative, because the rules of addition and subtraction in integers, so copy the largest absolute value, which is negative, since negative 2 is the largest than, or large value than positive 1, so the answer must be negative, so negative 1. So 54 plus 2 over negative 1, so 56 over negative 1, or simply as negative 56. So another example. Evaluate 2 over 3a squared minus 3b if a is equal to 3, b is equal to negative 2. So same procedure, so simplify by substituting the value of our variable. So 2/3 copy because it is already given, so 2/3 times the value of our a is 3, so 3 squared minus 3 times the value of our b is negative 2. Then so simplify, so 3 squared is, it gives us an answer of positive 9. So 2/3 times positive 9, so negative 3 times negative 2, since they are in the same sign, so that becomes positive 6. So 2 times 9 becomes 18 over 3 plus 6. Then 18 divided 3 is equals to 6 plus the remaining 6. So you have to add it. 6 plus 6 becomes 12. Or you can use the other techniques, which is the cancellation. So if you know cancellation, you can use that method or technique. So you have to cancel this one, so 3, this one 9 and 3, so 9 divided 3 becomes 3. So this one 3, so the remaining is 3, so 2 times 3 becomes 18. 6, I mean 6. 2 times 3 becomes 6 plus the remaining 6, so it comes up with the same answer. So if you know the techniques, you can use it. So if you know the techniques, you can use that one. So last example, so evaluate the expression if a is equal to 2/3 and y is equal to 1/2. So all the values of our variables are in fraction. So here 3, our given expression is 3xy cubed. So what we are going to do, so copy 3 because it's given, so substitute the value of our variable. So the value of our x is 2/3, the value of our y is 1/2. Then simplify. So first this one, because you have to solve first if there's an exponent, so solve it first. So 1/2 cube, or quantity of 1/2 cube, it gives us an answer of positive 1/8. So 3 times 2/3, so 3 times 2, 6 over 3 times 1/8. Therefore 6 over 3 times 1/8, so you can cancel this one. So 6 over 3, so 6 divided 3 becomes 2 times 1/8. So 2 times 1 is 2 over 8. So our answer is 2 over 8. Or simply as, you can reduce it by dividing both numerator and denominator by 2. So 2 divided 2 is 1, 8 divided 2 is 4. So it gives us an answer of positive 1/4. So always remember, in evaluating algebraic expression, so first is identify the variable and its given value. Number 2 is replace or substitute the given value of the variables in the expression. And number 3 is simplify the expressions using the order of operation and the rule of integers. And also don't forget to analyze the given expression, because you will not be confused if you are going to understand what is the given expression. So I think that's all for today's video. I hope you have learned a lot from my tutorial. Thank you and God bless everyone.